Welcome back to our channel and VINAY KUMAR Basics of Physics. Dear students, in this video we are going to discuss about one of the most important 8 marks question in the chapter of thermal properties of matter, that is related to the intermediate first year physics. Intermediate first year physics నుంచి థర్మోడైనమిక్స్ లో మిస్ అయితే నెక్స్ట్ చాయిస్ ఉన్నటువంటి క్వశ్చన్ న్యూటన్స్ లా ఆఫ్ కూలింగ్. సో ఆ క్వశ్చన్తో పాటు ఒక ప్రాబ్లం ఇస్తాడు. ఆ రెండు కాంబినేషన్ ఎప్పుడు మిస్ అవ్వదు. సో మోస్ట్ ఇంపార్టెంట్ క్వశ్చన్, లాస్ట్ వరకు చూడండి, ఓకేనా? సో 8 మార్క్స్ క్వశ్చన్లో ఫస్ట్ పార్ట్ నేను ఫస్ట్ ఎక్స్ప్లెయిన్ చేస్తున్నాను, దాని తర్వాత లాస్ట్ ప్రాబ్లం కూడా ఉంటుంది. ఖచ్చితంగా వీడియోని లాస్ట్ వరకు చూడండి. సో చిల్డ్రన్, వీడియోని స్టార్ట్ చేయకముందు నాకు ఒక రిక్వెస్ట్, ఒక ఇన్ఫర్మేషన్ ఏంటంటే, మన ఛానల్లో ఫస్ట్ ఇయర్ ఫిజిక్స్ సంబంధించినటువంటి చాలా టాపిక్స్ ఉన్నాయి. ప్లేలిస్ట్లో మీకు ఏ చాప్టర్ వీడియోస్ కావాలో ఆ చాప్టర్ హెడ్డింగ్ని ప్లేలిస్ట్గా ఇచ్చాను. ఆ ప్లేలిస్ట్ ఓపెన్ చేసి దాంట్లో ఉన్న వీడియోస్ని చూడండి. ఒకవేళ ఏదైనా ఒక టాపిక్ మీకు మిస్ అయింది, వీడియో లేదు అంటే ఏదో ఒక వీడియోకి ఫస్ట్ ఇయర్ వీడియోకి సంబంధించి ఒక కామెంట్ ఇవ్వండి. ఏ టాపిక్ కావాలో ఆ టాపిక్ని, ఇంటర్మీడియట్ ఎగ్జామ్కి సంబంధించిన టాపిక్ని కామెంట్ ఇవ్వండి. నేను ఇమీడియట్గా దాన్ని అప్లోడ్ చేయడానికి ట్రై చేస్తాను, ఓకేనా? So let's go to the topic. Here the question is there: state and explain Newton's law of cooling. State the conditions under which Newton's law of cooling is applicable. That is the question, children. Here Newton's law of cooling. So when a body can cool, when a body can gets heated, if any body can loses heat, the body becomes cool. If any body can gains heat, it becomes hot. Clear? So according to the Newton's law of cooling, here the laws of heat is directly proportional to the temperature difference of body and its surroundings. That is called Newton's law of cooling. Laws of heat of a body is directly proportional to the temperature difference of a body and its surroundings. This is what we call Newton's law of cooling. So children, here in general example, for example, this is the one body, thus we having some temperature of 200 degrees Celsius and its surrounding temperature is nearly 30 degrees Celsius. Clear? And just you can go for next body, that should be having some temperature of here some 150 degrees Celsius and its surrounding temperature is here 30 degrees Celsius. So here this is having some 200 degrees Celsius and this one is the 30 degrees Celsius. Here the heat is transferred from body to the surroundings. Here this is situation 1 and this is situation 2. Clear? According to the Newton's law of cooling, the loss of heat is directly proportional to the change in its temperatures. It means that here how much difference is there? 200 minus 30, 170 degrees Celsius. Here it is what? 120 degrees Celsius. So among these two cases, in the first situation, loss of heat is more for the first case. Clear children? So first body undi 200 degrees Celsius temperature undi, its surrounding temperature ఏమన్నాం 30 అంటున్నాం. ఇక్కడ 150 ఉంది, సరౌండింగ్ టెంపరేచర్ 30 degrees Celsius అంటున్నాం. ఈ ఆబ్జెక్ట్ అనేది ఎంత హీట్ లాస్ అవుతుందో ఆ లాస్ అయ్యే హీట్ అనేది దేని మీద డిపెండ్ అయి చెప్తున్నాడు? డిఫరెన్స్ ఆఫ్ దోస్ టూ టెంపరేచర్స్. 200 minus 30, 170. Here 150 minus 30, 120 degrees Celsius. సో దాన్ని మనం ఏమంటామంటే న్యూటన్స్ లా ఆఫ్ కూలింగ్. సో మీకు అర్థమయ్యేలా చెప్పాలంటే సింపుల్గా, ఎక్కువ ఎవరికైతే డబ్బులు ఎక్కువ ఉండేవో దే హ్యావ్ సో స్కోప్ టు ది ఫర్ మోర్ డొనేషన్. ఎవరైతే ఎక్కువ అమౌంట్ ఆఫ్ అడిషనల్ మనీ ఉన్నారో వాళ్ళు ఎక్కువ సర్వ్ చేయడానికి స్కోప్ ఉంటుంది కదా. తక్కువ అమౌంట్ అంటే బతకడానికి లేని వాటి ఇంకేం దానం చేస్తాడు? చాలా ఎక్కువ అమౌంట్ రిచ్ పీపుల్ అయితే ఎక్కువ దానం చేయడానికి స్కోప్ ఉంటుంది. అదేవిధంగా ఇక్కడ టెంపరేచర్ డిఫరెన్స్ అనేది డిసైడ్ అయి ఉంటుంది. ఆ టెంపరేచర్ డిఫరెన్స్ మీద ఏం డిపెండ్ అవుతుంది? లాస్ ఆఫ్ హీట్. సో ఇక్కడ అమౌంట్ ఆఫ్ హీట్ ఎక్కువ ఉంది కాబట్టి అది ఎక్కువ లాస్ అవుతుంది. ఇక్కడ అమౌంట్ ఆఫ్ హీట్ తక్కువ ఉంది కాబట్టి దట్ విల్ lose the or lost the less amount of heat. That is what we call Newton's law of cooling. The loss of heat of a body is directly proportional to the temperature difference of that particular body and its surrounding temperature. So first 8 marks part lo manamu ee Newton's law of cooling definition rasin tarvata we have to derive the expression for Newton's law of cooling. So children, this is the body that is having some temperature T, and this is now its surrounding, that should be having some temperature T naught. Clear? Let capital T is the temperature of the body and T naught is the temperature of the surrounding temperature. That's why here we are writing dq by dt, loss of heat. That is showing on here like minus. Minus means what? Loss of heat. dq by dt is proportional to the T minus T naught according to the Newton's law of cooling. So these two are directly proportional. To equate them, we are using one constant. dq by dt is equals to k into T minus T naught. This is a small k. It is the proportionality constant. So it is equation number 1, children. When the body is at temperature T, the amount of loss of temperature is dt. The amount of loss of temperature is what? dt. So to understand that, simply here S is equals to what you have? M into dq by dt. This is what? Specific heat. From that what, right? dq is equals to M into S into dt. Clear? So in this case dt is the change in temperature. How much it is lost? dt. So then simply here dq is what? Amount of heat loss. There is one body, it is there, that should be having some temperature T, and the difference of temperature is how much? dt. Within the time dt. Then the amount of heat loss should be given by the formula here. Now simply here heat lost by the body, is given by formula. మనకి ఏవైతే ఒక బాడీ ఉందో ఆ బాడీ ఎంత హీట్ లాస్ అవుతుంది అంటే మనము ఈ ఫార్ములా రాయొచ్చు. dq is equals to m into dt. Here dq is what? Amount of heat loss. What is m? Mass of the body. What is s? S is the specific heat. సో దీన్ని s తో అయినా చూపించవచ్చు లేదా c తో అయినా చూపించవచ్చు. సో అయిన తర్వాత dq రాసిన తర్వాత we are dividing on both sides with dt. So like this, dq by dt is equals to m into s into dt by dt. This is equation number 2 now. Equation number 1 is dq by dt. This is the dq by dt and this is also dq by dt. While we are comparing equation number 1 and 2, what do you observe, children? Both are equal. Let's say it is equal. So simply here you can write like this also, dq by dt is equals to minus k. You can write, no problem. dq by dt is equals to minus k of T minus T naught. When comparing these two, from 1 and 2 we can write, what we can write? M into S into dt by dt is equals to minus k of T minus T naught. Children. So దీని నుంచి మళ్ళా we are writing like this, dt by dt is equals to minus k by ms of T minus T naught. We can write. So here again this entire thing should be taken as capital K. dt by dt is equals to k of T minus T naught. Clear? So from that again we can bring this side, this one, dt by T minus T naught is equals to k into dt. So after that we have to, so this is equation number 2 and this is equation number 3 and this is the equation number 4, children. integrate on both sides. Integrate the above equation on both sides. On both sides. What do you get, children? Integral dt by t minus t naught is equals to integration k dt. So then, children, it is in the form of integral 1 by x dx. That is what, children? Log x. Log x. Therefore, what is it, children, here? Log of t minus t naught is equals to minus kd plus c. Minus kd plus c. This is the another equation of the Newton's law of cooling. This is the first one. It is also this is one also. Here simply what, right? Equation number 1 is the Newton's law of cooling, and equation number 2 also it is another form of Newton's law of cooling, and equation number 3 and 4 also different forms of the Newton's law of cooling. From the again same formula we can write here t minus t naught is equals to e to the power of minus kd plus c. T minus t naught is equals to e to the power of minus kd plus c. Then what, right? T is equals to t naught plus e to the power of minus kd plus c. So this is the another form of the Newton's law of cooling, children. So from that again what, right, here T is equals to T naught plus e to the power of minus kT into e to the power of c. E to the power of c. And from that what, right, T is equals to T naught plus e to the power of minus kT into c. Here c means what, children? E to the power of c can be taken as c. So there are some conditions for Newton's law of cooling. Children, conditions for Newton's law of cooling is not only important for 8 marks, and it is also most important for 2 marks questions. That's why listen very carefully. So there are some conditions. The first condition is the loss of heat due to the conduction is negligible or zero. Clear? There is no loss of to the process of conduction. Okay? And the loss of heat is only due to the streamline flow of heat. That means what? Forced convection. In conduction process, the medium particles are vibrates and they can pass the heat to the next surrounding particles. That is what we call conduction. Convection means what? The heat is transferred from one place to the another place because of moving of fluid layers. From one place to the another. That's why here in this case loss of heat is because of forced convection only. And third one, during the loss of heat we have to assume that, or there is one condition is that the temperature of the body is uniformly distributed it. That means if you can take a body at every point it should be having same temperature. That is the third condition. And fourth condition is here the temperature difference is moderately between the body and surroundings up to 30 Kelvin. So moderate means it is not bigger, it is not smaller. That's enough. And when the convection takes place, it is like a forced convection. For forced convection here, for high temperatures also, for high temperature difference also, it is applicable. So these are the conditions for Newton's law of cooling. The same thing I wrote here. First thing is what? Conditions for Newton's law of cooling. The first thing is here, loss of heat is negligible by the conduction process is almost all zero. Negligible, that means what? Nothing. And only when it is due to the convection. The loss of heat is because of only convection process. Just now only told you the convection is because of moving of fluid layers from one place to the another place. And second condition, loss of heat occurs in the streamlined flow of air, that is forced convection. So when the body in the atmosphere, the heat is transferred from the surrounding because of forceful air. And third one, temperature of a body is uniformly distributed over it. If you can take the body has same temperature at every portion of the body. And fourth one, the temperature differences are moderately up to 30 Kelvin. And however, if the heat body is due to the forced convection, valid for large temperature differences. That means loss of heat body. Loss of heat body is due to the force convection. It is valid for large temperature differences also. These are the conditions for the Newton's law of cooling. So children, in that case we discussed e to the power of c can be taken as c. E to the power of c can be taken as c in the Newton's law of cooling equation. So if we can draw the graph between the temperature difference and time. Here in the first graph, loss of heat is initially more and after that is decrease and should be like this. So here we are taking the temperature difference. We are taking the temperature difference on the y-axis. On the y-axis. That's why here what I have to say, at this point dt is more. Dt means what? Loss of heat, nothing but. So when we have for less time, delta t is more. When t value is increase, delta t value is decrease. Inversely it is coming. So from this graph also what you have to say, when time increases, the loss of heat is also decreases. Initially it is more and after that is decrease slowly. That means loss of heat is cooling and we will write it is minus dq by dt we will take. Clear? And next thing is children, in the second graph we can plot the graph between log of t minus t naught and t. That is also, it is the giving like this, inversely proportional. It is also inversely proportional. So the value of slope k is nothing but it is the value of c. Clear? That should be intercept at the point on y-axis. Where it can touches, that should be taken as here c. Clear children? So from these two graphs what you have to say, Newton's law of cooling is clearly explained in these two graphs, and these two graphs are given authentication for the Newton's law of cooling. So children, this is the first part of the Newton's law of cooling. What is Newton's law of cooling and what are the equations for Newton's law of cooling and what are the conditions for the Newton's law of cooling and what are the graphs for Newton's law of cooling. Clear? Up to here in 8 marks, 6 marks is completed. Now we go for third one. Third part what is? Nothing but here there is one problem, it is there, for that 2 marks it is there. Okay, let's go for that. That is, a body cools down from 60 degrees Celsius to 50 degrees Celsius in 5 minutes and to 40 degrees Celsius in another 8 minutes. Find the temperature of the surroundings. So ఏమన్నాడు చూడండి, ఒక బాడీ ఉందట, దాని టెంపరేచర్ ఎంత ఉందంట, ఫస్ట్ 6 డిగ్రీ సెల్సియస్ ఉందంట. ఆ 60 నుంచి 50 డిగ్రీ సెల్సియస్ అంటే హీట్ లాస్ అయిందనమాట. ఎంత హీట్ లాస్ ఎంత పట్టింది ఇక్కడ 5 మినిట్స్. మళ్ళా 50 డిగ్రీ సెల్సియస్ నుంచి 40 డిగ్రీ సెల్సియస్కి వరకు వచ్చేసింది. వచ్చినప్పుడు ఈ 50 డిగ్రీ సెల్సియస్ నుంచి 40 డిగ్రీ సెల్సియస్ రావడానికి ఎంత టైం పట్టిందంట, 8 మినిట్స్ పట్టిందట. పట్టినప్పుడు ఆ బాడీ చుట్టూ ఉన్నటువంటి సరౌండింగ్ టెంపరేచర్ని ఫైండ్ అవుట్ చేయమంటున్నాడు. సో ఇక్కడ ఫార్ములా ఒకటి ఉంది చిల్డ్రన్, దట్ ఈస్ d theta by dt is equals to k into theta average minus theta naught. Here theta naught is what? Theta average is the simply theta plus theta naught by 2 or theta 1 plus theta 1 plus theta 2 by 2, and theta naught is the surrounding temperature. What is surrounding temperature? Surrounding temperature. So then what right here, d theta by dt means nothing but here d theta by dt is nothing but theta 1 minus theta 2 by theta 2 minus theta 1 by whatever maybe theta 1 minus theta 2 by t, change in temperature by time. Okay, so now here you can substitute, you can use the same formulas here. Then let's see here, d theta by dt is equals to k of, this one is theta 1 plus theta 2 by 2 minus theta naught. What we are saying, d theta by dt means what? Theta 1 minus theta 2 by dt is equals to k of theta 1 plus theta 2 by 2 minus theta naught. So this is the formula we are going to use now. What you have to find out? We have to find out the surrounding temperature theta naught. Here the first condition is there, condition 1. what it is 60 degrees Celsius to the 50 degree Celsius. How much time taken? 5 minutes. So then here theta 1 is 60, theta 2 is 50. 60 minus 50 by dt, how much time? 5 is equals to k of theta 1 plus theta 2. 60 plus 50 by 2 minus theta naught. 60 minus 50 means what? 10 by 5 is equals to k of 110 by 2 minus theta naught. Clear? From that, what children here? We need some space, that's why I am erasing this one. Last one children problem ni 10 by 5 is equals to here k of 110 by 2 55. So k of 55 minus theta naught. This is equation number 1. That is for what? First condition. Now condition 2. What it is? 50 degrees Celsius to 40 degrees Celsius. For that, how much time required? 8 minutes. Now you can write in that formula theta 1 is 50, theta 2 is 40. Then what is here? 50 minus 40 by how much? 8 minutes. So k of 50 minus what is here? Average. 50 plus 40 by 2 minus theta naught. Theta naught. 50 minus 40, 10 by 8. 10 by 8 is equals to k of 90 by 2 theta naught. That means what? 10 by 8 is equals to k of 45 degrees Celsius minus theta naught. This is the equation number 2 children. So what is equation number 1? This is equation number 1 and this is equation number 2. Now you have to divide the equation number 1 and 2. Then what are children? 10 by 5 by 10 by 8 is equals to k of 55 minus theta naught by k of 45 minus theta naught. K cancel. Then what do you get here? So children, I need some space, that's why I am erasing this one. మీకు నోట్స్ రాసుకోవాలనుకుంటే జస్ట్ సింపుల్గా వీడియో పాజ్ చేసి రాసుకోండి. దీని ఎట్లా రాస్తున్నానంటే 10 by 5 into 8 by 10 is equals to what rate? 55 minus theta naught by 45 minus theta naught. 10 cancel. Then what do you get? 8 by 5 is equals to 50 minus theta naught by 45 minus theta naught. Now do cross multiplication. So what do you get? 8 of 45 minus theta naught is equals to 5 of 55 minus theta naught. So 8 into 45 minus 8 theta naught is equals to 5 into 55 minus 5 theta naught. So here 45 into 8, 8 5s are 40 and 8 4s are 32, 360. So 360 minus 8 theta naught is equals to 55 into 5. 5 5s are 25 and 5 5s are 22, 275. So 275 minus 5 theta naught. 5 theta naught. Here 360 you can take this side and you can bring this side. 360 minus 275 is equals to what? 8 theta naught minus 5 theta naught. So 3 minus 275. So 5 is there. 15 minus 1, 85. So 85 degrees Celsius is equals to 8 minus 5, 3. 3 is not that. Then theta is equals to what? 85 by 3. So 85, 3, 6, again 24. Yes, what is theta naught is equals to 28.33. 28.33 degrees Celsius. Theta naught is what? 28.33 degree Celsius. So children, this is the surrounding temperature of the body for the given problem. So dear students, if you can understand this one, like, share, comment the video. My request is, if you can understand my subject, you have to share my channel to your friends also. Okay, thanks for watching.